Jane and some friends are playing kickball after school. Jane kicks the ball so hard, it flies up and over the fence. As it rises and falls, its distance above the ground is a function of time since the kick measured in feet. I have my original function. First thing it says is find the velocity and determine what velocity is at t equals 1. Well, let's just take the derivative. So we have A, and we want f prime of t. We take the constant originally out, and we're going to use the power rule, which says that if we have x to the n, the derivative is nx to the n minus 1. I have 3t squared plus 12 times, and again, I'm going to use my power rule, 2t, plus 8 times, the derivative of t is just 1, and the derivative of a constant is 0. We get minus 90t squared plus 24t plus 8. This is f prime of t, which is the same as v of t, or the velocity of t. And now we want to know what it is when t equals 1. When t equals 1, we get v of 1 equals negative 90 times 1 squared, which is still negative 90, plus 24 times 1 plus 8 is negative 58. And that is velocity, and this is in feet per, and it's not telling us, it just says that t equals 1. We'll have to say 1 minute. So this is feet per minute. But I just made up, if you don't have units, you don't have units. And B says I want the acceleration. So determine the acceleration when t equals 1. So this is the velocity. And now we know the derivative of the velocity is the acceleration. I can either write it as t double prime of t, which means the second derivative, which is the same as the derivative of the velocity, which is equal to negative 90t squared plus 24t plus 8. Nope. The first derivative and the velocity is equal to that. Now, what I want to do is I want to find the second derivative of the original function, which is equal to the derivative of the velocity. And again, I just do the same thing I did before. So I take the negative 90 out, and then I use my power rule. X to the n equals nx to the n minus 1. So I get times 2t plus 24 times the derivative of t is 1 plus 0, because the derivative of a constant is always 0. So I would get here negative 180t plus 24. And I want to know what the acceleration is at t equals 1. This is equal to the acceleration. And if I want to know what the acceleration is at t equals 1, it's minus 180 plus 24, which is equal to negative 156. And if we use the units that we were using before, it would be feet per minute squared. Well, I know what's happening is this is definitely slowing down at 1 minute. This is our last slide. An object's distance from its starting point at time t is given by this equation. What is the speed of the object when the acceleration equals 0? Well, we're given this distance formula. So I'm going to start with d of t is equal to t to the third minus 6t squared minus 4. And I'm going to say the derivative of that is equal to the velocity, which is equal to the derivative of t. Again, I'm using my power rule. I'm just going to keep writing it. Hopefully you'll remember it. So that's going to be 3t squared minus 6 times 2t. And the derivative of a constant is still 0. So we get 3t squared minus 12t. Well, it didn't ask me anything about that. Why did I have to do that? Because I need the derivative of that. I need the derivative of velocity to get my acceleration. So I'll write the second derivative of distance is equal to the first derivative of velocity, which is equal to acceleration. And so now I'm taking the derivative of this, which is going to be 3 times 2t minus 12 times 1, which is equal to 6t minus 12. And it says, what is the speed of the object when its acceleration equals 0? Well, when does my acceleration equal 0? My acceleration is equal to 6t minus 12. And I want to know when it's equal to 0. I add 12 to both sides and divide by 6, and I get t equals 2. So now I know at 2 seconds, my acceleration is 0. But that's not what it's asking. It's asking what is the speed of the object. So now I have to go back to my velocity function. My v of t is equal to 3t squared minus 12t. And I want to know what the velocity is when the acceleration is 0 or at t equals 2. Now again, I just plug things in and I know that my velocity at 2 is equal to 3 times 2 squared, which is 12, minus 12 times 2 is 24, which gives me negative 12. And again, it's not really telling me in what form we are, but there's my answer, negative 12, because that is my velocity, which is the same as the speed. This should actually say velocity because speed is actually always positive. That is not a great way for that problem to be worded. It should say what is the velocity of the object when its acceleration is 0.